So it's this question. If you want to take a photo of it, you can, or hopefully you have your classwork packet handy. All right, modeling on wheels. The Boards and Blades Company manufactures skateboards and inline skates. The company can produce a maximum of 20 skateboards and pairs of inline skates per day. That sounds like a constraint. It makes a profit of $25 on a skateboard and a profit of $20 on a pair of inline skates. It sounds like a profit function. Okay, the company's planners want to make at least 3 skateboards, but not more than 6 skateboards per day. Okay, that's another constraint. To keep customers happy, they must make at least 2 pairs of inline skates per day. Another constraint. Okay, so part A is to list the constraints. Okay, so we'll say let X equal the number of skateboards. And let Y equal the number of inline skates. And then part A, so the first one, so the company can produce a maximum of 20 skateboards and pairs of inline skates per day. So that's going to be X plus Y has got to be less than or equal to 20, right? The number of skateboards plus the number of inline skates has got to be less than or equal to 20. Also at the very end, because I know this is like a challenging part of the course, and this might even be, some of you might feel that this is the most challenging. That's why I'm happy I can spend an extra day on it. At the end of the classwork packet, I actually scanned the textbook, which is available to you through my math lab if you go to like view textbooks. But still, you have it here. You can read through it, linear programming. And then there's the fundamental principle of linear programming.
What page is that?
This is on page 47 and 46. So at the beginning of all of my classwork packets, I create like a table of contents. And then you can see at the appendix, it says textbook explanations of linear program and answers to textbook questions. So that's on 38 to 49. So review that, just look through it. And the best thing about textbooks and why they cost so much money is that they have worked out examples with explanations. Okay, and when I was a student, before we had my math lab, I know I'm like a dinosaur sort of, before we had my math lab and all that, I had to use textbooks only. So I would cover this up with paper, and I would try solving the problem on my own. And then I would remove the paper and check. And then the best thing about it is wherever I was getting stuck, I could read. So there's one example, example 7 there, and then there's another one on the back, example 8. This one is washers, dryers, maximizing profit. And then just at the very back, it has this procedure for solving linear programming, just like old school textbooks offer it. I love it. Yeah, textbooks were heavy, but I still kind of like, obviously I printed this up, I still kind of like paper. And I like to put the little posties on it. I like highlighting. It makes it more interactive. The more interactive you can be with this stuff, the more it's going to stick. And the more fun you'll kind of have. Sounds weird, right? But it can be fun. All right. The company can produce, it makes a profit of $25 on skateboard. So that I'm going to jump to part B, just because that's our profit. That's our objective function. They put that in the middle of the paragraph, of the whole paragraph that's given. It's profit. So we want to maximize And it says $25 on a skateboard. So it's $25 on the skateboards plus $20 on the inline skates. So that's going to be equal to our profit. The company's planners want to make at least 3 skateboards. So at least 3 skateboards. So it's got to be, X has got to be greater than or equal to 3, but not more than 6. So X has got to be less than or equal to 6. So we can even write that as 1. So we can write that as 3 greater than or equal to X is greater than or equal to 6. Both of them are acceptable. Okay, to keep customers happy, they must make at least 2 pairs of inline skates per day. So Y has got to be greater than or equal to 2. So here's our constraints. Okay, so now we have to graph those constraints to find our feasible region.